Okay, next we're going to show you how acid reaction works, this effervescence on carbonates. So most of the carbonates dissolve in weak hydrochloric acid. So geologists typically take acid with them to test carbonate rocks to see if they're made out of calcite. So this is calcite, calcium carbonate, and it reacts vigorously with acid. The reaction is temperature dependent, so it reacts better on a hot day than a cold day. So you have to be careful of that. But what we're going to do, I'm going to put a couple of drops of acid on this, and then Mara's going to zoom in, and you're going to see bubbles in the drop of acid. So are you ready?
Mm-hmm.
Here we go. So I can see the bubbles forming. It's fizzing pretty well. There's a big bubble in the center. Ooh, just burst. But that is pretty vigorous effervescence of calcite. So I'm going to go ahead and wipe this one off. So calcite effervesces really strongly. Another mineral that effervesces strongly is aragonite. Aragonite is also calcium carbonate, but it's a different structure. This is called a rhombohedral structure, and many of the carbonates are this structure. This is different. But let's see how it reacts. If I can put some on this face here. Oh yeah. Reacts pretty vigorously on aragonite too. So these two react quite easily. Okay, now let's try this one. This little pink guy is called rhodochrosite. It's a manganese carbonate, and it doesn't react quite as strongly as calcite. Let's see what it does. I don't know how your zoom works. Oh, I'm not seeing much. I almost need a hand lens to see it. I don't think there's much reaction. So I need, do we have a nail handy? We don't.
Yep, in this box.
All right, so what we're going to do, I'm going to scratch it. Now what scratching does is it makes a powder on the surface. And the reactivity of the powder is more reactive than the big surface. So the reason I grind my coffee in the morning before I brew it is because it's much more reactive as a fine grind than as big pieces. So I'm going to put that on there, and you can see, oh yeah, there is some effervescence of the powder. So rhodochrosite is one where the powder is reactive more, you can see the reaction more in the powder than you can in the non-powder. Okay, now the last one I want to do is dolomite. These two are both dolomite. This one looks just like calcite. This one is a common form of dolomite. It has kind of these orange platey crystals. The problem with this sample is it might have some calcite in it too. So I wanted to get a pure dolomite. And I got a nice clean surface here. Well, there's some scratches. Let's do this surface. Okay. If I put it on here, I see no reaction. Nothing. Let's scratch some up. This has been done before. I'll put it on the scratched area. And yes, there is some reaction of the scratched dolomite. So it is very helpful to have a hand lens when you do these tests, because if I had my hand lens, I could go like this and focus in and see those bubbles really clearly. I don't have it with me today, but it's a very useful tool to have hand lens plus acid. Okay, let's try it on this stuff.
What does the acid reaction turn into?
So the reaction, what the acid does is it breaks up the cation from the anion, so it breaks the calcium from the carbonate, and then that carbonate reacts with the acid to make, what does it make? It makes bicarbonate and it makes CO2. So you're releasing CO2 when you put the acid on. Now, I squirted on there, I don't really see any reaction on here. If I were to scratch one of these, I should get some reaction. This is a little bit of a tricky one to scratch, but there's a scratched area. And there's a little bit of activity. It's hard to see without a hand lens. Now I'm going to mention one more thing. So the way that geologists usually use this tool in the field is when you find a carbonate rock to see if it's a dolostone versus a limestone. And if it's a dolostone, it often has a fair amount of calcite and dolomite in it. And you put a drop on and look with your hand lens, you can see which is dolomite and which is calcite in the rock. So it's a very handy tool. That's effervescence.